Okay, hello students. Here I am trying to prove equation of a line in vector form, parametric form, Cartesian form in a three-dimensional Cartesian coordinate system. So let me go briefly on each step as how to go about. As you see here, you have a three-dimensional x-axis, y-axis, and there's a red line. Now this red line contains a point. So this is the given point. So I'm going to write here R naught. R naught is a point, let's see, is given to you as, I'm going to write x1, y1, and z1. Okay, so the textbook gives x0, y0, and z0. So I'm going to take it like x1, y1, z1. So this R naught basically is that point. So naturally, if there is a point here, this will have a position vector. I'm going to use the position vector here from the origin. So this is, let's call this, so if R naught is a point of the coordinates of this R naught, then we will call this as R naught as a vector. So we call this R naught, and that is written as in the component form as x1, y1, then z1. So remember, this is the coordinate. The parentheses represent the coordinates, but this R naught is a vector from 0. So this is the origin, and this is R naught. I hope that makes sense. Then, what is R now? What is this R? So this R is any point. So R is x, y, z represents it's any point on the line. So it moves. So this point. So this point which you see right here, it is x, y, z. So this point is x, y, z. But it can move around here or anywhere. But if this is the position, it will have a vector. It will have a position vector from here. Okay, see? So that is, let's call this as R bar. So please be careful. This represents a vector from the origin to the R. So let me write this here. So R is x, y, z, but the R, this lowercase, represents the vector. So it is the directed line. So it is direction this one. This is that R bar. This is the R naught. Okay. So this is will use this. This represents the component form. It is x, y, and z. Okay. So two things taken care. Then also, they are going to give us a vector. So this you can see very clearly a green vector which is v bar. So what they give you is v bar is a vector which is parallel. So this is given to as vector a, b, c. Again, this is given in the component form. So this vector is parallel to this one. So I'm going to write down R naught. So R naught. So I have a vector. Let's see. You will see there will be one vector right here, which I want to make a solid black color. So this is the main part, which is the focus here. So there's a vector from here to here. So P R naught to R. I want to get a vector. So what is this vector? Now this vector is parallel to the vector v bar. So this part is a so let me write this as green color. So this vector, the black color vector from 0, from R naught. So this is R naught to R is parallel. So because this vector is parallel, we want to know how many of these green ones can fit here. So there will be always either, is it 2 of this 2? Is it 1.5 of this over here will fit a black color? So how many vectors can we fit in? So that means we can write down this black color vector as So this black color vector is can be written as some scalar multiplier. Maybe is it two of this green one, or is it 1.5 of green one, or is it 3 of those? So how many of those pieces fit that black color? So we want to make those equal. So this vector equals what? How many of those? So and that's why I'll call this as parameter. So that's the. So I'm going to use parameter. What does parameter means? Is a variable that I use, and I will call it that maybe t is a variable, but sometimes t confuses with the time in velocity acceleration with the t represent time. So in this case, I will call this one as a scalar something in alpha, beta, gamma. I can put a lambda here. So that's the symbol stands for this parameter. So this is black color is some lambda times, so this scalar times the v, vector v. I hope that helps. So I'm going to write it right here. This is lambda time vector. Now we can use the vector addition. This part O. Now look at this O to OR. So put this. This is the important one. Now O to R. So or OR is OR. This vector. So this vector from O to R, this vector is same as I can add O to R naught plus R naught to this one. Okay, that's because of the how we add two vectors. So if I have my starting point here O, and you want to figure out this vector is same as going from 0 from origin to R naught. And from this add to this is same as, and you can create a kind of, remember that it is nothing but I can create a parallelogram kind of a thing. So this is the sum. So this is the sum of those two vectors, the diagonal that you see here. So that diagonal is the sum of those two vectors. Okay, so just wanted to show that what we learned long back. Now let's plug it in. So OR is this R, so this is the R vector. And OR naught is R naught, so that's R naught. And then plus, and this is the green one, lambda. Okay, so this is called in the vector form. So another way to write this is let's write in the linear form R bar. So if this is R bar is also because of this xy, we can write it as xy plus yj plus zk. See, you can write it like this also. So I'm gonna write this as. So from here, let me go write down. This is xy yj plus zk equals then R naught. So what is R naught? This is because this one is x1 y1 z1. It is x1 I plus y1j plus z1k. So I'm going to write it here. So this will be x1i plus y1j plus z1k plus lambda times, and because this vector here, this one, v is ABC, we can write it as also, so AI plus BJ plus CK. See? And then you can use just a regular multiply, use the distributive property here. See? And we can write this as, so this stays the same. So this one I will combine x1. So this x1i, we can combine this one will be lambda xi, lambda a, because you're multiplying the first one, ai. So together, then plus, let's put this together, that is the y1 plus lambda times b, which is b, so this is b lambda, and this together. So this is j, which I forgot here. So this is the j plus b lambda j, and plus, then you use Then you use this zk, so zk plus, and then this lambda multiplies to c, so it becomes c lambda. So we can write it as lambda times c k. And so it's like combining. So therefore, this one is I, this is I, so x becomes equal, so this is another way to write also is xi+yj+zk equals, you get x1 plus lambda ai plus y1 plus, I missed here lambda here, so this one I missed here. So this is y1j plus lambda, this I missed. So then this one is y1 plus lambda b, that is j, and then here there's a k, we can write down this as z plus lambda c 1, which I missed, I think. So this is z1, yeah, and then k. There it is. So this is also vector form. See? So xi+yj is, or you can also write directly as, okay, x, y, z is x1 plus lambda a, y1 plus lambda b, comma, z1 plus lambda c. So that also is correct. So just wanted to show everything that this is vector form, or you can directly write this. I just wanted to show how do you get that. Another thing is we want to know what is that parametric form, and what is parametric form is. काम जो भुर्गे आते पोतपोतांनी वेगळे वेगळे प्रकारचे एक्स्ट्रा पर्सन कमी नाव गेलं का बरं किती भाषा Okay, I'm just finishing this. So parametric form. So now I can see this x component is same as this one. So let's write an x. So I'm going to use this part. This x is same as this. So let's write it. X is x1 plus lambda a1, and this we can write it as. Then also, let me separate this. This y will be equal to this one, so that y equals y1 plus lambda b, and then again I can use this z is same way. So z equals z1 plus lambda c. Okay, and then finally we subtract. Okay, so finally what we write here. So when you write in this form, I think it's already written down. I should have written this as, instead of writing like this. So x is that y is the same, again I'm writing here lambda b, and z is z1 plus lambda c. And you're done. So this is in the parametric form. There's another way to write this is, from here, let me write this again, how to write Cartesian form is, this from here, x is x1 plus lambda a1, you can subtract x1 here, both sides, that will give you, this crosses out, you get x minus x1 equals lambda a1, and then you divide by lambda both sides. So this goes away and you get, sorry, not lambda, we divide by. So this is lambda a1. This now it's not a1, it's just a a. Okay, so you divide by a here. Dividing by a, you get this. So this crosses out. Sorry. I'm very much in a hurry. Oh, my wife is waiting. Anyway, just so divide by this. So this crosses out. So the lambda that you get in this part, so the lambda is x minus x1 over a. So this is one thing. You will also see if you start working on the other one. Let's see if I write down y is y. So I got one of this. Let me show here. So if I start with the second one, so this is the main box that we put. This one I'll write y is y1 plus lambda b. Now you can subtract y1. That becomes y minus y1 is lambda b, and now you divide by b. See, and this crosses out, you get lambda. So that also is lambda. This also is lambda. So what if we learn is the Cartesian form, that is x minus x1, which I missed, is same as y minus y1 and equals, and you can work out this one. If you work this out, you get z minus z1 over c equals again lambda. So this is how you get the answer. So this will be z minus z1 over c. So three different ways. Either you write vector form is of this one, or this one is straight away. Then we have parametric form, and this is Cartesian form. Okay, now the question, let me take one example. How do we apply this? So now you know the proof. Oh, there you go. There was a line, I'll just conclude. So there was a line and it had a point. So they have to give you a point, okay? Without a point, you cannot find the equation of the line. And this line also has to be parallel to this one, okay? So either they give you directly a vector which is parallel, or they can say, okay, there's a line whose equation, the equation of this one could be given as x minus 4 divided by 3, and I'm going to write there and see, and then you should know which one is to be used at the ABC is the denominator. Now let me take directly one example. So there's a question here. So here you're given a problem, right? So let me write this. So write the equation of a line containing the point. So basically the moment you know this is the point that is given to you, which is R0, and I'll call the point is x1, y1, and z1. See, that's straight away you know the answer. So and it's parallel to a vector which is given. Now this means it is 4, this is 4, and this is in the component form, and this is minus 5. So this is like your A, B, and C. See? You already know A, B, C. So once you have this vector form, you want to write this in the vector form. It is x, y, z equals, you can see it is x1 plus lambda A, y1 plus lambda B plus z1 plus lambda C. Okay, and then that's the answer. So x1 is this one minus 2. So this minus 2 will go right here, so minus 2 plus lambda times A is 4. So this is the 4. So it is 4. And then y1 is 1 plus lambda this 2. Okay, I multiply here, better to show that multiply, and then comma, Mr. here, this is comma here. And then z1 is 3, so it is 3 plus lambda times negative 5, and we can put it in a nice order. So this answer is x. So x, y, z is minus 2 plus 4 lambda and 1 plus 2 lambda, and this is 3 minus 5 lambda, and you're done. So this is in the in the vector form. Or you could also write directly R bar is R0, whatever it is. You could write this also, but I just want to show this is in the vector form. If you want to write in the parametric form, x equals x1. So you have to write x equals x1. x1 is right here, minus 2, plus lambda a1. It's the same thing what we are writing here. So lambda a1 is 4, so lambda times 4. So you can write. So basically you're just writing the same, it's the same thing, x equals y equals. So in the parametric form, x is this, so it is -2 plus 4 lambda. Then it is 1 plus y is 2 lambda, and z is 3 minus 5 lambda. And then if you want to write in the Cartesian form, and this is how it writes, z minus z1 over c. So all you do is x minus, and put those values a, b, c. So a, b, c is here. Those are the ones which go in the bottom, a, 2, and -5. And this one, so this x1, y1, z1 will be here. This will be minus. So because there's a minus by default, that negative and that negative, which is right here, will become positive 2. We just write the opposite. So this is 1, this is +3, become -3, and you are done. That's all it is. So I can change this question another way. So what if this same question was asked, instead of saying parallel to a vector, just changing this question, everything stays the same. So everything stays, so I'm going to keep the same point, the R0 is the same, -2, 1, 3, but parallel to a line, and whose equation is given by, let's see, x plus 4 over 3 plus 4 over 3 equals y minus 2 over 1 equals z plus 7 over -2. What's this? So they may give you a line, so you're supposed to figure out one equation of a line that is through the point -2 and 1 and 3, and this line is parallel to another line, but that line has equation given to it, so there is a directed line segment. So this is like maybe a vector whose component are given as 3, 1, and minus. So those are like A, B, C. And maybe at the point, maybe here, this is -4, 2, and 7. That point is -4, 2, and 7. -7. So my point, we don't want this point. We only want to know that vector. See, they gave you the equation, and all we want to figure out is what are the direction what are the direction ratios also they are called. So this is like that A, which, what did I write? I forgot what number. Okay, it was, did I write 4? Okay, I'll just take it as 3. So these are the main numbers. It's like an orange color, 3, 1, -2. So you want to find the equation. It's the same formula. Says everything stays. What changes is the x plus 2. The top will remain the same. The top will remain the same. What changes is only this number. Instead of 4, 2, -5, this number will be 3, 1, and negative. Done. That's all you do. And you can also write in the Cartesian form, and if you want to write in the parametric form, so you can also write this x equals, so x equals x1. So here this one is +2, but it is actually -2, because here it is -2 plus this number 3 times lambda, y equals, this is 1 plus 1 lambda, and z equals, this is 3 plus -2, so this will be -2 length. You're done. And not only that, they could also ask an angle between the, so one more question could be find the angle between the two lines. So he may be given one line, so just taking the same thing as what is the, so let me create a problem here. So find angle formed by two lines, okay, I just want to write 2 lines given by, and they may be given is x plus 2 over 3 equal -4 So this is one line, and the second one is maybe x minus 4 over 2 minus 2 will take y plus 3 over 5 maybe equals z minus 1 over, I'm just taking negative 4. Okay, so see, so there are two lines, so two lines they cross each other this way. So what's happening is they gave you one of the vector here. So that's what I'm saying. This 3, 1 decides this vector. There's one vector on the first line maybe, and that is given by, this is 3, 1 and minus. So those are like A, B, C. And there's another vector maybe here. So this one is along the one which is 2, 5 and minus 4. Those are the ones, like 2, 5 and negative. Okay. So once we get this, we can always move this towards here, the point where they meet. So this point, this vector which you see here, I can pull it down and say, okay, now it is here. So this vector, which was there, now I put it down. See, it is like this now. Or this vector I can graph here, and then so there is an angle theta, and you know cosine theta. What is cosine theta? From dot product definition is, it is the vector first one, the second vector, or directly, sorry, I made a mistake here, it is u bar, the vector first vector, and then you take the magnitude of this. See? So all you do is, there's a vector here, so you see, you have to do, this is like your vector maybe a1, b1, c1, this is like a1, b1, a1, a2, a3, b1, b2, b3, so you multiply this 2, so 2 times 3, so this will be 2 times 3 is 6, plus 5 times 1 is 5, plus negative 4, and this will add to 8. So that takes care of the top or dot product. But how do you find the bottom? Now this is, for this one, if this is the vector, how you find the magnitude of the vector? Always remember it is square root. So if this was the first one, this one, then you write 3 square plus 1 square plus negative square. You just do little calculation, 9 plus 1 plus 4, 9, 10, and this becomes 14. So that becomes square root of 14. And then you do another one. For this one will be, you take the square root, 2 square plus 5 square plus 6 plus negative 4 square. So this will give you 4 plus 25 plus 16. Okay, this 16 and this will be 20, and add to 45, right? Square root of 45. This is square root. And then you can put this together and you directly use cosine inverse of, and every 6 plus 5 is 11, 19. So this is 19 over square root of 14, 45, and you get the answer. So a lot of different types of questions we're asking. One is directly maybe, or sometimes parallel, or find out what is the angle. I hope this takes care of understanding how to find equation of our lines in 3-dimensional space, in vector form, Cartesian form, and parametric form. Hope that helps. Thanks for watching. And next video I'm going to do is, if you see, so this is the one that I tried to show a chart. You already have taken the picture of this, but just in case. So here is that I was trying to show the line through the point, and I took x naught, y naught, z naught, because the textbook of your college textbook uses that. So I took x naught, y naught, z naught, and this is the point x, y, z parallel to v. The v has a b, c, and I use the same thing. So the vector form is this, and then the parametric, and the last one. Okay, hope that helps. So my next goal is to make a, what is that? How to find the equation of plane. So that's the I think that's the one. Did I do it? Oh, this is here. So the last video on vectors will be on this one. You can see this part. So that's the one I'm going to do next. Is equation of a plane in a 3D. You have this blue plane, and you can see again the blue plane has a point on it. You have to have a point on it, and then there is the xyz, which can be anywhere around, but there is a one green color vector which is normal vector called perpendicular. So if this is the paper, and this is like a vector which is perpendicular to the whole plane, and you can see you use this, and I'm gonna make that video on that. Hope that helps. Okay, thank you for watching.